to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on queues. A queue is a FIFO, that is, first in, first out data structure. This means the first item to enter the queue will be the first item removed from the queue at the other end. A good analogy for a queue is a physical queue. New items enter at the back of a queue, like new people joining a queue. Items are removed from the front of the queue, like those people being served at the front of a physical queue. A queue will have attributes of queue, max size, as well as pointers to the front and rear of the queue. A queue will have four methods: enqueue, which is used to add an item to the back of the queue; dequeue, which removes and returns the first element in the queue; isEmpty, which tests if the queue is empty; and isFull, which tests if the queue is full. There are two key ways to implement a linear queue like the one we've been looking at. The first of these is that you can have a list or array, and every time an item is removed, all the other items in the list are moved along one space. You can see here we've removed Bob, and Jim, Sam, Joe and Tim all move along one space. The key problem with this method is that as the size of the list grows, the process of shifting all of the elements along one space when one is removed becomes very time-consuming. An alternative method is to use our list or array and attributes for front and rear of the queue, and as something is removed from the front of the queue, we simply move the pointer to the front of the queue to the next item in the array. If something is added at the far end of the queue, we put it in and we move the pointer to the rear end of the queue. You can see that the key problem with this one is that as items are added and removed from the queue, we end up with a space at the start of our array. One way to overcome the problems we've just seen is with a circular queue. With a circular queue, we still have a queue of fixed size with pointers to the start and end of the queue. When an item is removed from the queue, the front pointer is adjusted to point to the next item in the queue. As you can see here, we've removed Bob, and the front pointer is moved on to actually point to Jim. When a new item is added, it is added at the next available space after the rear pointer. Here in the example, you can see that after we've added Dan and we go to add Nat, Nat actually scrolls round to the start of the circular queue. The main difference with circular queues is that they're slightly harder to code because you have to consider the position of the front and rear pointer to know whether you need to loop back to the start of the array. A priority queue is a special kind of queue where new items are added to the queue in a location that is based on their priority. Items are still removed from the front of the queue. Consider an accident and emergency department. As new people join the queue, they are assessed as to the urgency of their medical needs. Those that require urgent treatment will be placed in front of those in the queue that have lower needs. There are many uses of queues in computer science. One of these is a print queue. This is where jobs that are sent to the printer are held in a print queue and then printed in the order they were received. Another example is the buffer that stores keyboard inputs as the user types so that they can then be dealt with in the order they were struck. As with earlier work in our data structures unit, the best way to secure your understanding is with some practical implementation. The first challenge I'll set you on this one is to build a circular queue. It should have methods for isEmpty, isFull, enqueue, and dequeue. To our queue class, we're going to add a method for nextDealer, and we're going to use it to create a program that outputs the players at a poker table starting with the dealer at the front of the queue. The nextDealer method should make it so that the person who was currently the dealer goes to the back of the queue, and the next person in the queue becomes the dealer. In the game, a player can only leave if it is their turn to deal, i.e. from the front of the queue, and someone can only join if there is room at the table, and they must join at the back of the queue. If the dealer deals the next hand instead of leaving the game, then the dealer moves to the back of the queue as we discussed earlier, and the next person in the queue becomes the dealer. Have a go at trying to implement this, and I'll be back to show you a solution to it in my next video. This time round, you should also try a second example of building a priority queue. This should have methods for isEmpty, isFull, NQ and DQ. Each item in it should be a tuple with the priority and then the item to be added. When an item is in-queued, it should go behind any items with the same or higher priority, but in front of those that have a lower priority. Use this to build a program that can be used in an A&E department where patients who arrive are assigned a priority and then added to the queue in the appropriate place. I'll also be putting out a second video that goes through a possible solution to this problem. That brings us to the end of this video on queues. Join me again soon when I'll be running through the solutions to the two problems we've set at the end. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.